Hey guys, it is Monday, April 13th. Hope you had a great Easter weekend. We are in advanced math trig, honors, mods 2, 3, and 4. We're going to continue our chapter that we started on Thursday. If you remember back to Thursday, we learned how to graph what were called exponential functions, which is always the first day of this unit when we're dealing a lot with exponents and bases and final numbers and things that we can do with exponents and, yes, your favorite word probably from last year, logarithms. So for today, a nice piece of paper out ready to roll. You will need a calculator. It does not have to be a graphing calculator, but it's got to have the word log and then natural log, which is the LN button as well. So if you need to take a second to get that out, that'd be great. Top left-hand corner, put the date, which is again April 13th, 2020. The title is simply Logarithms for today's notes. So put logarithms at the top, and I'm just going to make this point very clear right from the get-go. Every time in mathematics you see a logarithm, you see the word log, whether it's LOG or, as you'll see later on, the letters LN, which stands for natural logarithm rather than a regular logarithm. When you see the word log, you immediately, and guys, the first thing you're going to write on your paper today in quotes in capital letters is, believe it or not, the name Ben. Every time you see logs, you think of Ben. Now, I'm just using the name Ben to remember what we're about to do, but Ben obviously stands for three different words: base, exponent, final number. Base, exponent, number. Okay? Every time you see the word log, every time, down below the word log, you've got some base, and that base is going to be raised to some exponent that's on the other side of the equal sign. And if you take that base and raise it to some exponent, of course you're going to end up with a final number. Oh, so every time you see the word log, guys, follow the bouncing pen here. We've got base, an exponent, and a number. Some base being raised to some exponent that's going to equal some final number. So if that's true, and that's what's going on with logarithms, I've got three problems here that are very basic, but yet show the different scenarios that could come up that you're going to have to deal with. So here we go. You'll just write these as we go. The first problem on this paper says log 2, 8 equals blank. If you had to fill in that blank with the missing number, and notice we're not using any calculators here. You cannot take a calculator and push log 2, 8 and hit enter. That doesn't happen. It doesn't work. It doesn't have that capability. The only log button on your calculator is what's called a common log that is understood to have a base of 10. We'll get to that later on in our notes. But for now, if you look at that problem, oh, it says log, doesn't it? And instead of panicking and saying, oh my gosh, I don't like logs, you love logs because watch how easy it is. You've got a base, an exponent, and a final number. The number that's over on the right side, on the opposite side of the equal sign, that all by itself is always your missing exponent. So to fill in this blank, if I take 2, I would raise it to what missing exponent to end up with a final number of 8? Well, I think it's pretty obvious that that number would be a 3, wouldn't it? Do you agree that if you took 2, raised it to the third power, you would end up with, of course, 2 times another 2, giving you 8. And so log base 2 of 8 equals 3. Okay? Problem number 2. It says log base 3 of 1/9. Again, notice all these we're going to think our way through. We're not going to turn to a calculator. It's not going to help. Now, let's think about this for a minute. Remember, it says log, doesn't it? So I've got a base, an exponent, and a final number. I would have to take 3 and raise it to what power to have it end up being 1/9? Well, the easy question is this. Obviously, if I took 3 and I did what? Squared it, right? 3 squared would give you 9. Well, since it's 1/9, oh, that 9 has been flipped over, hasn't it? So anytime a number's been flipped over and creates a fraction, doesn't that mean we've got a negative exponent? So -2. -2 would be, 3 to the -2nd power gives me 1/9. And then the last basic example here, it says log 49/7 equals blank. If you look at these, when you try your homework tonight and you're not thinking and you're just rushing through, a lot of people will put 7 here because they see a 49, they see a 7, and they just think, hey, missing number must be 7. Or they'll put a 2 here, thinking if you took 7 and squared it, you'd know. This 49 is the base. I have a missing exponent, and I want to end up with a final number of 7. So the question becomes, what would you do to 49 to have it turn into a 7? Guys, do you agree that if we took 49 and square rooted it, if we took 49 and square rooted it, it would turn into 7, agreed? So we must be square rooting that base of 49. And if you'll remember, maybe not, but you should, a square root box is really a 1/2 power. Guys, 49 to the 1/2 power really means the square root of 49. So it is possible that your missing exponent can indeed be a fraction because, again, a 1/2 power is really a square root box. So 49 raised to the 1/2 power, meaning let's take 49 and let's square root it, is going to give me 7 for my final number. Okay? Now the missing number could be any one of those 3 locations. So now that we've done some of these, let's try this. What if the blank is now the number on the left side? Can we fill these in? Okay, just kind of get on a roll in some rhythm here. Ready? It says log, doesn't it? Every time I see the word log, I think of the name Ben. I have a base, an exponent, and a final number. If I take 5 and raise it to the 3rd power, I get what number? Don't you dare put 15. That doesn't say 5 times 3. It says 5 raised to the 3rd power. 5 times 5 times 5. You should be writing 125. Look at the next one. It says log base 4 of blank equals -3. If I told you to translate this into English or into a normal math problem, again, it says log, so I'm thinking base, exponent, final number. You just follow the bouncing pen. I have a base, an exponent, and a final number. So isn't this really 4 raised to the -3rd power, and they want to know what's the missing number? Now remember, that's a negative exponent. That does not produce a negative answer, does it? I always pretend the negative sign isn't even there. If I covered up the negative sign and I asked you, what's 4 to the 3rd power? 4 times 4 is what? 16 times 4 is 64. So the answer is 64, but because it's a negative exponent, that number gets flipped. So you would indeed put 1/64 in the blank. And finally, if I took 8 and raised it to the 1/3 power, right? Base, exponent, final number. Hey guys, if then me. If a 1/2 power, remember up here, a 1/2 power was really a square root box. A 1/3 power, an exponent of 1/3, is really a cube root box. So if I take 8 and raise it to the 1/3 power, I'm really taking the cube root of 8, which I hope we all know is 2. Agreed? Because 2 times 2 times 2 gives me 8. A cube root box means what number can you multiply 3 times in a row to get the number that's inside there. And then finally, put now one more time, last thing on the front of my paper, what if the number down below is the number that's missing on your problem? Notice the blank can occur in any one of the 3 locations. If I said translate this question here into English, we're really doing what? I have a missing base, I have an exponent of 3, and a final number of 125. So they're really asking, what number would I cube to get 125? And wouldn't the missing number indeed be 5, right? Kind of already did that problem up there. What number would I raise to the negative second power to get 1/49th? You're really thinking what? What number would I square to get 49? But because it was a negative exponent, that 49 got flipped over, correct? So would you agree the missing base would be 7? And finally, the last one on the front of my paper. Oh boy. What number would I raise to the 1/2 power to end up with an answer of 1? So let's think about this. What number, now, would I raise to the 1/2 power? Remember, a 1/2 power, an exponent of a half, is really a square root box. So the square root of what number would equal 1? Well, wouldn't that number missing there be the number 1? Isn't the square root of 1 going to give you 1? So my missing number on this problem would be 1. So guys, just focus and concentrate, and you should be able to find the missing number in any logarithm problem as long as you rely on your old buddy Ben. Okay? Now on the back of that, real quick, 2 things to point out. What is a, quote, common log? So the next thing on your notes, put star and put the big question. What is a common log? The answer to that question, I'll just come out and tell you, it's any log that has a base of 10, exclamation point. Anytime you have a logarithm and it has a base of 10, that's called a common log, and that's the log button on your calculator. Now notice on this put so, and in my first example, it just says log of 100 equals blank. If you do not see a base, it is understood to be a 10. If you don't see a base on a log question, it's understood to be a 10. So since my base is understood to be a 10, this is called a common log. And I'm really thinking 10 raised to what exponent would give me 100 for my final number? It's pretty obvious if you took 10 and did what? Squared it, you would get 100, correct? So 2 goes in the blank. Okay, next one. It says log of 0.001 equals blank. Again, this log does not have a base, so it's understood to be a 10. If you want to, you can put a 10 down there. So I'm asking 10 raised to what power gives me 0.001? Well, guys, think back to what? 6th grade math when you learned decimal places? Remember when you counted decimal places, we had the tenths, hundredths, and thousandths? So do you agree 0.001 is really 1/1000th? So it's 1,000 that's been flipped over. So 10 raised to what power would give you 1,000? Wouldn't that be 3? But because it got flipped over and created a decimal, must be -3. And then finally here, again, it says log. I don't see a base. I'm still using Ben, right? Base, exponent, final number. My base is 10. My exponent is 4. And my final number would be what? Well, if I take 10 to the 4th, that means 10 times 10 times 10 times 10. Doesn't that just mean I'm going to produce 4 zeros and get an answer of 10,000? Okay? Note, this is why we got to have a calculator out. If I just said, hey guys, what's the log of 47? We cannot do that in our head. You agree? My base is understood to be 10. So that question's really asking me, if I take 10, I would raise it to what exponent to end up with 47? Well, guys, you know 10 to the first would be 10. 10 to the second would be 100. So this answer's got to be 1 point something, right? But we just don't know what it is. It's impossible. So pull out your calculator. That's the common log button that is on your calculator. I'm literally going to type in what it says. I'm going to hit log 47, hit enter, and I'm going to go to the nearest three places. You'll see why towards the end of this chapter when we show all the real life applications for these things. I'm getting 1.672 on my calculator. Okay? Finally, last thing in our notes, put another star, and we're posing another important question. What is a natural log? Remember, a common log was a log that was understood to have a base of 10. A natural log is the LN button on your calculator. LN stands for a logarithm that's natural. And it's anything that has a base of E. Now, E is a symbol in math very similar to the symbol pi. Remember when I told you what is pi? You originally learned that pi was 3.14, blah, 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 and it was a big, long, irrational number. Okay? E is a big, long, irrational number that was developed to use in natural logarithms. Again, you'll see why later in the chapter. Actually, if you typed in E on your calculator, it's 2.718, blah, blah, blah. So anytime you see ln or use the ln button on your calculator, that means a logarithm that's natural. It's a natural log instead of a common log or a regular log. And these, you strictly rely on your calculator, right? What's the ln of 8? Now notice that's really asking me, my base is understood to be an E. When you see ln, it's a base of E automatically. E, which is 2.718, raised to what exponent would give me 8? Okay, we don't know that, so go to your calculator, hit the ln button, and just hit ln 8. Hit enter, and I'm getting 2.079. So we're literally practicing one more on our calculator here. If I said, what's the ln of 52? What's the natural log of 52? You hit ln 52, hit enter. 3.951 is what my calculator says. 3 decimal places on logarithms. Now this one we can do without a calculator. Okay, I'm going to let you think about this one for a few seconds. ln1 equals blank. Do not use your calculator and somebody tell me what number to put there. Okay, think about it. Since it's an ln, a natural log, isn't the base understood to be an E? So this question's asking E raised to what power gives you 1? Do you guys agree that anything raised to the what? 0 power always gives you 1? Remember that rule? Any base raised to the power of 0 always gives you an answer of 1. So 0 is the missing number there. And then there's a star by my last question. This also should be answered without the use of a calculator. And this is an important note as well. What the heck is the ln of E? ln E equals blank. If you think about that, again, my base is understood to be E. I would raise it to what exponent, right? I've got a missing exponent, and I want to end up with E for the answer. Oh, well, obviously, if I take E and raise it to the first power, it's going to stay E, isn't it? So, guys, remember when we start solving equations in a couple of days, if you ever end up with the ln of E on your paper, it's really just the number 1, okay? All right, that's a pretty good introduction to just good old logarithms. Your homework, so this is due tomorrow on Tuesday the 14th, right? Tuesday, April 14th, your homework for today the 13th, which is due tomorrow by noon on the 14th, is just to fill in these 8 log questions, okay? There they are. I'll leave it right here. I think you can see all that pretty clear. Pause your video at this point. We've got log 381, log 6 136th, log 4 blank equals 3, log 36 blank equals a half, Log question mark 27 equals 3. Log question mark negative 2 equals 1/3. That is possible. Log 1,000 equals blank. Notice there's no base there, so it's understood to be what? 10? What's the log of 0.1? What's the log of 253? And finally, the ln of 14.6. Obviously, those last two, you're just going to pull out your calculator and practice using that. And again, round those to the nearest 3 places. Okay? So 10 problems. Just fill in the blanks. You're going to get just 1 point for each one you get right. So it's just like a little 10-question quiz on basic logarithms. Trust your brains, think your way through, and shoot me a picture of that by tomorrow at noon, okay? Thanks, guys. See you then.